Today we will be discussing using Avogadro in calculation. The amount of particles in a mole is defined as 6.022 times 10 to the 23rd. This fact can be turned into a conversion factor. That conversion factor will look something like this. I will have 6.022 times 10 to the 23rd particles per 1 mole, or I will have 1 mole for every 6.022 times 10 to the 23rd particles. This conversion factor can then be used inside of dimensional analysis or inside of a stoichiometry problem. For example, how many particles are in 63 grams of carbon dioxide? If the molar mass for carbon dioxide was 44.01 grams per mole. First thing that I'm going to do is I'm going to go ahead and I'm going to translate this problem into math. So that will look like this. How many particles will turn into X particles of carbon dioxide? Rn is my equal sign and then 63 grams of carbon dioxide. Since I'm currently in grams, I would need the molar mass for carbon dioxide, which was defined inside the problem as 44.01 grams per 1 mole. Grams would need to be in the denominator, as grams is currently in the numerator with my given number. That would leave me with moles of carbon dioxide. Moles of carbon dioxide is not the desired unit, however. I want particles of carbon dioxide. So that means that I would go ahead and use Avogadro's number and use that conversion factor to help me get there. Currently, I'm in moles of carbon dioxide, so I would need the version of the conversion factor that had moles in the denominator. That would be this left version here. That left version would just be plugged in directly, allowing me to cancel out moles of carbon dioxide, leaving me with particles of carbon dioxide. Since particles is the desired unit, I could go ahead and cancel out all of the other units and plug everything into the calculator. This will look like multiplying everything in the numerator and dividing by everything in the denominator. The numerator contains 63, 1, and 6.022 times 10 to the 23rd. Calculators typically do not appreciate times, 10, and a caret, so instead I have substituted it for the EE button. This will turn into just a capital E in your calculator. So I have 6.022 E23, and I will be dividing by everything in the denominator, which in this case is 44.01 and 1. Once I plugged that into the calculator, I got this number out, 8.620449898E23. 63 has two significant figures, so I would go ahead and round it to that first decimal place, as that is the second sig fig and the last number that I care about. Then I would look over to see if I needed to round up. 2 does not make me round up, so my final boxed answer would be 8.6 E23 particles of carbon dioxide.